And welcome back. As we go ahead and take a look at another programming example, let's go ahead and create a recursive method for a factorial call. And of course, we're expecting this to return a value. And so we've gone ahead and set up a method here. So I have public static int factorial, and we're passing in a num. Now, we want this, of course, to be able to handle factorials. And typically with factorials, that means that they have to be positive values, or at least starting at 0. So the very first thing I'm going to do in this recursive method is I'm going to handle those values that aren't 0. So I'm going to say if num is less than 0, I'm just going to return an error. I have a non-valid number. And let's actually just go ahead and have it exit. Now, obviously, we could, of course, handle this other ways, but this is perfectly fine. Now, it does that if statement. If it's not valid, it's going to break right out. We can then go ahead and check on our two cases. The first case, of course, would be to handle, if you think about factorial, and we're looking at integers here, 0 and 1 both behave the same way. 0 factorial evaluates to 1, and 1 factorial evaluates to 1. So we want to go ahead and say, well, if num is, let's say, less than or equal to 1, because that would include both 0 and 1, what do we want it to do? Well, we can go ahead and predict what it's going to return. Since it is a int method, it is expecting a return type, so we're not going to print line statement, we're simply just going to return 1. Now we, of course, need to set up our recursive cases. So this is going to be our else. And if you know the definition of factorial from math, you know that it's just each number times the previous number. So, like, for example, we did factorial 3, it's going to be 3 times 2 times 1 times, etc. All right, and so right now I have just a 0 in here as a placeholder for a number. But if I change this, let's say, to 5, that means we're expecting to do 5, 4, 3, 2, 1. So let's go ahead and kind of use that as our statement here. So we can go ahead and just jump right to a return. And we know we want to return num times, and it's going to be some previous value. So it's typically, again, we look at our pattern, 5, 4, 3, 2, 1. I can think about, oh, it's just 1 less. So let's go ahead and just call our method again. So it'll be factorial of num minus 1. Let's go ahead and put a semicolon on there. And now we have a quick method we can test out. Let's actually make this really small so we can test this. Let's just test it with 3, because we know what 3 times 2 times 1 is. That just should be 6. And this is a great way for us to test our method, is with a small value like this. And if we run it, we get 6. All right, great. Now what if we plug in one of our base cases here? So let's say 1 and 0. So let's just plug in 0 like we originally had. If I run that, we get 1. And if I change that to 1 and run it again, we get 1. Perfect. What about 2? If I run 2, we get 2. So again, a great way for us to see how easy it is to construct some of these recursive methods. You can start seeing how there are certain ways that these are going to be really helpful for us to create certain things that are going to be much more efficient as a programmer to write. Could I have done this iteratively? Yes. I mean, I probably would have had to use some loops and stuff like that, but it's a very easy way for us to handle this if we are setting this up with recursion.